Hi folks, this is question 7. It's a stem and leaf plot. It's a back-to-back stem and leaf plot. So we just need to stick in the numbers. That's for the left hand side, that's the heart rate. And that's all of those values that we're putting in. So we're putting in all of those. Remember, it's the leaf that will go out there on the outside. Those are all the leaves. They're the second digits of each number. The heart rate side, then we're going to put all the bottom row in. Therefore, if we pick any value in there, then for example, that value there, that would represent 83 when you put the stem and the leaf together, and that's on the heart rate side, obviously. If you were to pick this one here, that represents 70, and that's on, well, they're both heart rate sides. The first one was after exercise, this was before exercise. That's the stem and leaf plot filled in anyway. And I think that was 15 marks. Right. We have to worry about the mean and the standard deviation then of the heart rate after exercise, and they give us the values here again. This is all calculator work really. You can put all the values into the table on your calculator and it should give you the answer. You just need to put it into statistics mode first, and we should get 93.3 for the mean and 15.1 for the standard deviation. Right, based on the stem and leaf plot, how has the standard deviation changed following exercise? Well, if we look back up here, we can see now that following exercise there's a greater spread in the data now. They're much more spread out. Before exercise they were all either 60 or 70 something, but now you've one person that's 71 and you've the another person at 113. Therefore, they're much more spread out after exercise. We can see that from looking at the stem and leaf plots. Therefore, we must say it's increased and a greater spread in the data. And that's all there. Then we have a scatter plot. We have to figure out which of these, well, a straight line, so if all the dots were in a straight line upwards like that, it would be 1, but they're not, obviously. There's a little bit of variation. This is an awkward one enough to see. We kind of have to treat that one there as a bit of an outlier. So if you ignore that one that I circled, they're very much close together then, and therefore it has to be 0.9. I know we can't ignore all of them, but when it's a one-off like that, we can call it an outlier. It definitely can't be the negative ones, because that would be where the line is going, where the dots are going down, so it would be like that. Therefore it has to be either 0.3 or 0.9, and 0.3 would mean that they're very well, that they're spaced out a lot basically. So 0.9 there, and we have to give a reason as well. You can just say something like that, almost in a straight line. Right, we're on to part B then, and the first part, it says margin of error. Therefore, when it says margin of error, straight away we know it's going to be 1 over root n, and n is just the number of people in the sample. Therefore, it's 1 over root 355, and that's 0.53 or 5.3%. 96 of the 355 finished the run in under 25 minutes. Work out the percentage of runners in the sample who finished the park run in under 25 minutes. Therefore, it's just 96 out of 355. That's how many finished it. and they want it as a percentage, so we'll just multiply it by 100, and when we round it off it's 27%. Now really that is p hat is what we're finding there as well, and because we should be able to guess that there's a confidence interval coming up, and we have to show the relevant calculations then. Well, to do the confidence interval, we're going to do p hat plus or minus 1 over root n, that's the margin of error. Therefore in this case it'll be 27% plus or minus the margin of error we said was 5.3%. So you can do that in your head. If we subtract them, it'll be 21.7%, and if we add it on, it'll be 32.3%. Therefore, if we look back up at the claim at the top, so the running commentator said that Galway run times have changed since 2019. It's reported in 19 it was reported that 24% of all runners finished the park run. So we can see then that 24% lies within the confidence interval. And therefore there's no change to the percentage who finish in under 25 minutes. So that's our conclusion then. If the percentage was outside of the confidence interval, then there would be a change. It would be far enough away then for us to consider it to have changed for the overall. So that's it. That's all we have to do for question 7 then.